That might be a good way to look at this. So if you look at that little guy standing there, little guy, he's just hanging out here. So if I want to, when I'm looking up at an object, so if I go from neutral to looking up, that is called my angle of elevation. Angle of depression is if you look at the horizon and you have to look down at something. So think of depression as me looking down at something, and elevation as me looking up at something. So once again, elevation is moving up, depression is moving down. So that's why we have those two kind of different definitions. So the problem is when you're reading one of these word problems and they talk about angle of depression and elevation, you have to know what object they're talking about. So if we look here, we have a lighthouse and a boat. Well, if I want to talk about the boat looking up at the lighthouse, you would say this is your angle of elevation. So that 35 degrees down here is our elevation. The lighthouse looking down would be our angle of depression. Ooh. And be very careful when you label these because they kind of make a box. They kind of make a box, and people oftentimes, let me just erase this elevation real quick to show you like an error that people put. People will sometimes draw the entire, that's aggressive. Let's make that a bit smaller. So some people will make the full box, and they'll actually put the angle of elevation right there. That is not where I want the angle of elevation. That is not from horizontal to looking up. That's from looking up to looking straight up. That usually isn't needed. I don't need to know if I'm looking at an object, what's the angle to me looking straight up. It seems like an arbitrary thing to do. So whenever you're drawing a picture of angle of elevation or depression, we have kind of two directions. We have our angle of depression. That is always from horizontal to looking down. And angle of elevation, that's horizontal to looking up. I know it kind of seems funny when I put my angle in here, but sometimes when you're just free on your own drawing pictures, we can put our angle of depression sometimes here, which we'll see normal when I'm drawing a picture, but as I'm describing it, it doesn't make sense. But when you're drawing that picture, a lot of times we'll put our angle of depression there. But remember what's happening here. This is the angle of me looking down to me looking at my feet, I guess, if a lighthouse had feet, I guess, which really isn't an angle I need to know. So when you're doing elevation and depression, I always think, what is that horizontal to either up or horizontal to looking at the object? All right, we'll do some practice with that in just a second with some birds flying. I do want to note that both of those angles are going to be congruent because they are what? Why are those two angles congruent? Always. Ellie.
It's just parallel lines.
Yep. Does anyone know what those angles are called when they're... Kate?
Alternate interior.
Those are alternate interior angles, so they're always going to be the same. So if someone gives you an angle of depression, you're like, I like talking about an angle of elevation. You can always change it. So if the problem says the lighthouse looking down at the boat at 35 degrees, you can say, I also know the boat looking up is 35 degrees. Because sometimes that's an easier triangle to picture, especially when you want to determine the height of the lighthouse. Sometimes it's easier to think about it as the elevation and creating this right triangle. So a lot of times we'll take, if I tell you depression, you turn it into elevation, knowing that they're both the same. All right, we have Marco training pigeons on the top of his roof. Hard to be on the bottom of your roof, isn't it? But anyway, so he's on the top of his building. He's going to classify each angle as an angle of elevation or an angle of depression. And then he notes that measure of angle 1 is 45 degrees and measure of angle 4 is 30 degrees. So let's go ahead and note that stuff over here. He's very, very particular with his pigeons, measuring his angles and such. And 4 is 30 degrees. Okay, Marco's on the roof. He's looking straight ahead and then he looks up at his bird. That's angle 1. Would that be angle of elevation or would that be angle of depression? Kate? That would be elevation. We're going to put angle 1 equals 45 degrees, and that is elevation. So 2 doesn't have an angle measure on it. What would the measure of angle 2 be? Oop. Almost had it and then lost it. Daniel?
30.
It's going to be 30 degrees. So if I kind of, let's cheat this. Let's cover up some of this. If we look at this, we have a parallel line. A parallel line, these are alternate interior angles, so they both would be 30. So angle 2 is going to equal 30 degrees. Would that be an elevation or a depression? Ella? That would be a depression. That is looking straight to looking down at an object. Make sure you're looking down at an object. Angle 3, what is the measure of angle 3? Ty?
45 degrees.
That would be 45 degrees. Yep. Alternate interior angle. That would make it 45 degrees. Is that elevation or depression? At angle 3, this one's a little bit different. Is angle 3 an elevation or a depression? Yeah. It would be depression because we're looking at the pigeon's point of view. The pigeon looking straight to looking down, that's definitely a downward angle at 3. So that is going to be a depression. I got this one. I bet you angle 4 is 30 degrees. And let's get the hard ones. Is that elevation or is that depression? Is that an angle of elevation or is that an angle of depression? No?
Elevation.
That would be elevation. A little easier if you can see them all at the same time, but sometimes it's a little more difficult if you have to draw the picture. So just if you're talking about angle of elevation or depression on a picture, just go back to these pictures and just determine how you're going to make that drawing. All right, we're going to do a couple examples together, and then you're going to be on your own. All right, the angle of elevation from a boat to the edge of a cliff is 38 degrees. So what do we got going on here? We got a boat. Let's draw a beautiful boat. That's a beautiful boat. Look at that. Whoa. Let's make a better sail. There we go. Kind of a sailboat of sorts. Just chilling in the water. And then all of a sudden he looks up and there's a big cliff. There's our big cliff right there. All right, then we say angle of elevation from the boat. So remember what elevation is. Elevation is going straight to looking up at it. So you kind of picture a guy in the boat. I'm going to cheat this and just say it's the front of the boat just to create my triangle. So we're thinking, I'm looking for this angle here, the one that shifts up like that. So let's draw a line from the boat to kind of make that right triangle that we're going to have to use. So I got myself a right triangle. And now let's put the information down here. If point A is 80 feet from the base of the cliff, how high is the cliff? So point A must be on the boat, because the boat's looking up, and they're basically saying, what's the distance to that cliff? So this bottom one is going to be our 80. I could also put my elevation. I did draw it. I didn't write it down, though. This is 38 degrees. And then it says, how high is the cliff? So the boat knows it's 80 feet away from the cliff. It knows when looking up at it, it's a 30-degree angle on their neck. They want to find out this height. Let's call it h. What am I going to use to find that height? Joaquin. We're going to use tangent. Would I use tangent inverse or would I use regular tangent? Someone besides Joaquin, because he told me it's tangent. Ellie? It'd be the regular one, because I actually know the angle. We're trying to find a missing side. So we're going to use regular tangent. We're going to go, okay, tangent of that 38 degrees is going to equal, would that be 80 over h, or would that be h over 80? I always forget. I get those messed up. It'd be h over 80, because it is opposite over adjacent. So we'd have h over 80. Well, that's nice, because I can multiply both sides by 80. That's the easier one. So we multiply both sides by 80, and I have h equals 80 times tangent of 38 degrees. Let's put this as like it's on the test. Let's round it to the nearest 10. What do we get if we plug this in and it's to the nearest 10? 63 even?
Wait, what?
63 point, nearest 10.
Oh,
Sorry.
2.5.
63.5?
63.
62.5. Okay. And that'd be feet, right? Are we okay with 62.5? Okay, cool. So 62.5 feet. That's how high that mountain or hill or cliff or whatever he's looking at is. I think on your homework, everything will be rounded to the hundredths. I'm okay if you round it to the tenths. Just know that when you get to the homework, before I forget to describe it, all the answers are on the very bottom of the last page. They're in tiny little print. I also have the answer key posted online with my work in case you got kind of stuck with the pictures. All right, but that's neither here nor there. Let's move on to another example. Example 2, you measure the angle of elevation from your eye, which is 5 feet off the ground, to the top of a light post to be 35 degrees. If you are standing 20 feet away from the light post, what is the height of the light post? I always like doing this one because there's an easy way to make mistakes on this one. Do you see with your feet? Okay, no, it does. But most other people see with their eyes, usually. So when I'm looking at angle of elevation, my horizontal comes from my eyeballs, not my feet. So we're kind of picturing eyeball level to going up. So as I kind of draw this picture, we didn't think about that on the boat because it's just a small little thing. We don't know where they're on the boat. But I got this person with a tiny little head, apparently. Little stubby arms. Oh, it's a good-looking fella there. All right. He's looking up at a light post. So let's draw a light post. I think my light post is going to look a lot like the guy, isn't it? Let's have a light post. We'll know it's a light post because it'll be yellow and it'll be beaming white. There we go. Yeah, that's nice, huh?
Fancy.
You think you guys are good at art. Check out that. All right, the error you're going to make in this one is you're going to draw your right triangle from the feet. Noah, this works for you because you see out of your feet. So it works for you. But we're going to say we can see out our eyeballs looking up at that. Now, connecting that to the light post will create my right angle. So my right angle doesn't happen at our feet. It happens at our eyeballs. So let's put some information down. You will measure the angle of elevation from your eye, that's 5 feet off the ground, to the top of the light post to be 35 degrees. If you are standing 20 feet away from the light post, what is its height? So let's look here. So we have a 20. We have a 35 degrees. Now, what I want us to pay attention to is we're not going to find the whole height of the light post here. We're going to find a chunk of it. So we kind of have two chunks of the light post. We have this bottom chunk here, and then we have this top chunk here. Let's call it X. What's the measure of this bottom chunk? That we should know. Yeah.
5 feet.
It would be the 5 feet because we had to raise this up 5 feet. So this would be our 5 feet. So the only thing I need to do is find X. What am I going to use to find X? Declan. We're going to use regular tangent because we know an angle. So we'll use regular tangent. We'll go, okay, tangent X, not tangent X, 35. I just said that we knew that angle. Why would I put an X there? Equals, would that be X over 20 or 20 over X? What direction would that go for tangent? Yeah. It'd be X over 20, which is nice because now I can just multiply both sides by 20 and I come up with X equals 20 times the tangent of 35 degrees. And like I said, I'm pretty sure, does the homework say something to the thing of hundredths place? Yes, it does. Let's just pretend I'm on my homework right now. What would this be to the nearest hundredths? To the nearest hundredths, yeah.
14 feet.
14 feet, that's to the hundredths?
Yeah.
Oh, yeah, 35, yeah.
Weird.
Yeah, that's nice, isn't it? Is that the height of the light post? No. What's the height of the light post? 19, because we have to add that 5 into it. So it's going to be 19. 19 feet is going to be our answer. That is that whole height. You know, out of any of my pictures I've drawn with a light post and a guy, that's not one of my worst. know if that bodes well to other drawings or this was just so good. I know we're not supposed to have phones in this classroom, but if you want to take pictures of that and save it, you can. I'm okay with that. I'm guessing you don't have your phones on you. I think that's why you're not taking them out, taking pictures of it. Okay.
Definitely.
Why would you want a picture of that?
Why would you not want a picture of that? Do you see that work of art?
Like a map.
That's a fair point. Mr. Pabian, that is a fair point. Why wouldn't you?
Why wouldn't you want a picture of that? All right, any questions on those two problems? Okay, if you look through your homework, there's a lot of word problems, but a lot of them do provide a picture with them. There's only a few of them you have to draw your own picture on. And like I said, if you look online, I do have my worked out solutions. So if you're not sure what the picture looks like, you get home and you're stuck, just look online and just see what the picture is and just make sure it makes sense. A lot of these are going to turn out to be tangent. Some of them are like cosine and sine, but a lot of them are tangent because they're finding heights of things. All right, the rest of the time is yours to work and ask questions. I did give you your review.